Welcome to Geometry for AP. Today we're going to deal with slopes of lines. This is topic 3, section 8. It is important probably that you write down at least the essential understandings, which is this right here in your notes. Okay, I'm not so worried about the vocabulary this time because it's pretty much just ideas. Okay, and so our first concept here is the slopes of parallel lines. If two non-vertical lines are parallel, then their slopes are equal. That means the slope of one is going to be equal to the slope of the second equation. Okay, if slopes of two distinct non-vertical lines are equal, then the lines are parallel. Okay, so that's the conditional and the converse there. We've reversed the process here. And then, of course, it says here any two vertical lines or any two horizontal lines are parallel. So vertical lines and horizontal lines. The reason why they tell you that is that vertical lines have no slope, and so therefore they have to make that distinction in discussing these definitions. So if I look at this equation here, 2x minus 3y is equal to 10, and I solve this for y and get it in y equals mx plus b form. So that would be minus 2x minus 2x, so negative 3y equals negative 2x plus 10. We divide by negative 3, and I like to divide each and every term by negative 3. And so then y is equal to 2/3 x minus 10 over 3. Okay, and so here we have our problem. Never seem to figure out why it does that. All right, so here we have y is equal to 2/3 x minus 10/3. Let's say I wanted you to write me two more equations that were parallel to this line. So here's my first one. Y equals 2, I'm sorry, all that stuff's going on there. 2, get out of there. 2/3 x plus 2. In my second equation, y equals 2/3 x minus 5. Where did I get the 2 and 5 from? I just made them up. What's the whole point I'm looking at here is I'm looking at the fact that all of these have the same slope. They both have y is equal to 2/3 x, and that makes them parallel. So if I wanted a line parallel to, let me grab my pen real quick here, to y is equal to negative 2. Now y is equal to negative 2 is a horizontal line at y is equal to 2. So an equation would be parallel would be y is equal to 3, or y is equal to negative 5. These are parallel, and if I wanted a parallel to the x equal, that's a vertical line. Remember, it has no slopes. So that'd be like x is equal to 2, or x is equal to like negative 3. These are all parallel to each one of those lines. All right. People always have problems with those horizontal and vertical lines. I will be testing that, guaranteed on the test. All right. And so then perpendicular lines. In perpendicular lines, it says if two non-vertical lines are perpendicular, then the product of their slopes is negative 1. That's the mathematical way. So the slope of number 1 times the slope of number 2 should equal a negative 1. And if you can do that and check that, then that means they're perpendicular. We also know them as being opposite reciprocals. So like if the slope of 1 is 2/3, the slope of the perpendicular would be negative 3/2. But again, there's no mathematical process for explaining that. And so when we get to this point in geometry in our math career, that we start saying that the multiplying the slopes together and get negative 1 tells me that those lines are perpendicular. And here it says any vertical or horizontal line and vertical lines are always perpendicular. All right, so if we go to this equation, negative 2x minus 5y is equal to 8, and I solve this for y, I'm going to add 2x to each side. So negative 5y equals 2x plus 8. Divide by negative 5 for each one of these things. Okay, and y is equal to negative 2/5 x minus 8 over 5. All right, and if I wanted to write an equation that was perpendicular to this one, okay, I want two of them. My first one would be y is equal, the opposite reciprocal of that would be 5 over 2, and it would be positive x plus 3. And if I want to do another one, that'd be y equals 5 over 2x minus 1. and that would be two perpendiculars to that original line. Where did I get the 3 and the -1 from? I just kind of made them up. What makes them perpendicular? The fact that the slopes, that this slope right here and these slopes can multiply to give you -1. All right, and so then if I go over here to this x is equal to 4 line, an x is equal to 4 line is a vertical line, straight up and down. And so the perpendicular would be horizontal, so that'd be like y is equal to 2, or y is equal to -2. Those would be perpendicular to x is equal to 4. And if I want to do the y is equal to 1, that's a horizontal line, so the perpendicular would be vertical, so that'd be like x is equal to 3, or x is equal to -2. That would be the perpendicular for our y equals. Once again, I'm going to test you on those horizontal and vertical lines. It is important that we start getting those down. All right, so here I want you to find the slopes of these two lines. Put them in slope formula. Slope formula, in case you don't remember, is m is equal to y2 minus y1 all over x2 minus x1. And I want you to take and find the slopes of each of these lines, and then we're going to look and see if they're parallel, perpendicular, or neither. So pause the video, find the slopes of those. I will be looking for this work. If there's no work, you're not going to gain credit for your notes. Okay, so let's see how you did here. You should have your slope. You should be able to look at them. And so the answer for this pair was they were parallel. The slopes are equal to each other. Make sure you have the slopes for those. I will be looking. All right, here's another practice problem. Pause video, find the slope of each line. Once you've found the slope of each line, compare them and see whether they're parallel, perpendicular, or neither. Okay, so you should have all the slope work done. If you take those two slopes together and look at them, they're not the same, and if you multiply them together, you do get a product of -1, so therefore those two lines are perpendicular. All right, let's try another one. Okay, here's two more sets of points. Again, pause the video, find the slopes of each of those lines, and look at them, see if they're parallel, perpendicular, or neither. Be able to have the work. If you don't have the work, we're not going to give you credit. Okay, so now that you have the work done there, let's check those. And the answer for this one is neither. The slopes are not equal, and their product is not equal to -1. Okay. If you have problems with those, make sure you have your work there. You can ask questions when you get to class. All right, so now we want to rewrite each equation in slope-intercept form, and it says then determine whether the lines are parallel or not. So if I take this first set of lines, the first one is y is equal to -x plus 6. That one is already in slope-intercept form. The other one we need to manipulate, so that'd be y is equal to a -x plus 20. The slope of the first one is -1. The slope of the second one is -1. Therefore, they are parallel. Okay. All right, so you already do 2 and 3. Here are the next two. Pause the video, do those two practice problems, and then we'll see. All right, for this one here, you should have some work of solving for y. I'm going to be looking in your notes and looking for that. These are not parallel. All right, if we go over to this other one, in this other pair, they were parallel. And so that's the symbol for parallel. So make sure you know that symbol. We all know that that's the symbol for parallel, and we tend to not mix that up with the number 11 if you've got some other words in there. So the lines are parallel. All right, make sure you have your work there. We'll be looking. All right, so here are some more equations already set up, and so we're going to get them in slope-intercept form, and this time we're looking to see if they're perpendicular. So we're looking to see if their slopes or so. So if I look at the first one is already set up, so the slope of the first one there, the m was -1. If I solve the other one for y, y is equal to x plus 20. The slope there is 1. So -1 times 1 is equal to -1, and so therefore these lines are perpendicular. Okay. For the second one here, those are special lines. This was a horizontal line, that's a vertical line, and therefore we know these lines are perpendicular. All right. So you need to solve this last one for y, and then we'll check and see how you did on that one. All right, so you should have some work solving those. Check your slopes, multiply them together, see what you get, and you'll find out they are not perpendicular. Make sure you have the work. We're going to be looking for your slopes. We're going to be looking for the fact that you multiply them together to check to see if you had a -1 product. All right, so when you're verifying parallel lines and you're looking for to see if they're parallel, you can't just go by looks. If you go by looks, we're not going to give you credit for that because you have no math to prove it. So the first, you need to find the slope of each line. So if I look at this, I want to find the slope of each line. So the first line that you could count, you could also do the slope formula, but I can count here. This is going to be, let's see, line 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9 down, and 1, 2, 3 to the right. So 9 down and 3 to the right for the first line, which is -3/1. The second line was 1, 2, 3, 4, 5, 6, 7 down, and 2 to the right. And so when I look at those slopes, and I go to compare them, I can see that they are not equal to each other. Therefore, these lines are not parallel. If all you tell me is they're not parallel and you don't have any work when you're doing your notes and homework and stuff, we're not going to give you any credit for that. You have to be able to provide the slopes for each of the lines. All right, so now if we're going to verify perpendicular, be careful for this one. Look at the scales of every graph. You should do that also for the first one that we just did a minute ago, but you should always look at the scale of what the numbers are going by. In this case, they're going by 1, but they could go by different numbers. I can actually make a graph look like they are not perpendicular at all, but actually be perpendicular by changing the scales of one of the axes or both of the axes. So if we look here, we need to find the slope of the first line and find the slope of the second line. So if I look at this, the slope of the first line was -3/2. The slope of the second line was 2/3. Multiply those lines together, I get -1, and therefore these two lines are perpendicular. They have their product of their slopes is -1. Please have this example written down in your work. You can use it to help you as you do work for other problems. All right, so here we got a nice little problem here. It says analyze mathematical relationship, which is one of the techniques we're learning throughout this year. And it says line 1 contains these points and line 2 contains these points. Well, but we're missing part of the second point. So the first thing I want you to do is determine the slope for line 1. So pause your video and find the slope of line 1. All right, you should have some work somewhere that shows the slope. The slope of line 1 was 2/3. Okay, so that's the slope of the first line. And so the second line, we're going to have to find the value of k. So if I go to slope, that's going to be k minus 0 all over -3 minus 3 equals, and we're trying to make sure that the lines are parallel, so we're going to have the same slope. All right. So let's do a little simplifying. That's going to be k all over -6 equals 2/3. It's a proportion, so we cross multiply. So 3k equals -12. Divide by 3, divide by 3, and k is equal to -4. Now you may copy down my work here, but I'm going to be looking for your work for the slope of the first line, so you better make sure you have that. And of course, k was equal to, oh my gosh, I got the wrong answer there. Okay, so that answer I uncovered there, the, whoops, that's weird. -2, that's not the right answer. The right answer is k is equal to -4. So there we have it. So make sure you have that example down. All right, so here's another one just like that, except for you didn't have to find the slope for this one. I gave you the slope. Go find the missing value for x. You may pause the video and work this problem. I'm not going to provide the answer for this one, though. I'm going to check this one when you come to class to see what you got. Okay. And remember, when you're done with the video, you can start your work on problems for the next day. I would especially do this if you are confident in certain parts of the lesson. Do those problems so that stuff that you're not confident in, you can work on in class. And that's the end of our lesson.